Hey guys, and welcome to my channel. Today we have a special guest, Baron Gong from the Origo Network. And Origo is generating a lot of attention recently. So Baron, can you tell me a little bit about Origo and what it's trying to do?
Hi guys, this is Baron from Origo. So what we're trying to do is the privacy preserving platform for decentralized applications. Well, it may sound a little bit abstract, but let me put it this way. If you think Monero and Zcash are the private version of Bitcoin, we're probably the private version of Ethereum. Monero and Zcash is basically doing privacy for transaction, but not for smart contract. And as you all know, that smart contract is essential for applications on blockchain. And currently, there's no privacy preserving technology on smart contract. And that is exactly what Origo is trying to do, the privacy preserving smart contract.
All right, so you're trying to preserve privacy. So in what terms is the privacy preserved? Can you give me an example of which aspects are my transactions, the amounts I'm sending into the contract, or the code itself, the smart contract itself, is that preserved?
If you're familiar with a smart contract, it's composed of a piece of code, right? And the code itself is not preserved because it doesn't make any sense to hide the code.
That's
But
true.
yeah, I mean, there are inputs and outputs and also the transaction amount. And those are the three very critical information. And usually they're very sensitive, like in finance or healthcare. And those three are the kind of things we're trying to hide in that smart contract.
Okay, so basically when people interact, say if they're buying a digital cat, then you don't know the exact amount of the currency that they sent or
Yeah.
the amount of information, that's right?
Yeah.
Oh, and even the data. So smart contracts can include data as well. Is that kept private too?
Yes. I mean, for example, if some application requires your identity check, it's not very ideal to expose your ID number or like your date of birth or something onto blockchain, right? And we can also hide that as well. And we feel like it's more important to have this kind of feature so that blockchain can be actually used in the future.
Right, right. So it sounds like magic, right? To preserve that privacy, especially when it's on a public blockchain. How do you preserve that and keep it away from the prying eyes?
Yeah, sure. That's a good question. We are using a cryptography method called zero-knowledge proof.
Mhm.
Someone of you may have heard of Zcash. They're using similar technology for transaction privacy. So zero-knowledge proof is something that, hey, let's say you don't know who I am or you don't know my data, but you can still verify that I am Baron, right? Or I still own this kind of data. That's the basic high-level idea of zero-knowledge proof. So with this kind of technology, what you can do is that without revealing the data itself, the data can still be verified and can be still used in whatever application computation and get benefits out of the computation of that data.
Right. So who can actually see it? So the contract owner, can they actually see the data that's being sent to them? Say, for example, my date of birth. I mean, there's two parties, right? So there's prime parties because people can browse the blockchain, and then there are people who are the contract owners. So in this case, you're using your zero knowledge proofs, and who can see what in this case?
Yeah, I mean, for like random people on the blockchain, their role of this smart contract is only about verification. So they cannot see any data of the smart contract, like any data you wish to hide, right? But as the contract owner or as the data inputter yourself, you still know your own data. But what you do is that you do the data in an encrypted fashion, and then we put that encrypted data into a zero knowledge proof, and everybody else on the network will just based on your proof to do whatever kind of application you wish to do.
Okay. So the contract owner can still see and verify it, but the other people cannot. Okay, in this
Yeah.
case, zero knowledge proofs are actually bigger inputs as well. So there's disadvantages to using zero knowledge proofs. How do you deal with that on Oracle?
There are similar technologies that other projects are trying to use to achieve similar things, like using trusted execution environment. For example, Intel SGX and also secure multi-party computation. And we've done an extensive research on all these kind of technologies, and we've decided to use zero-knowledge proof because, well, one is that there are some schemas and some tools of zero-knowledge proof that's very industry-friendly, meaning that they're not just in academic phase. They've been used for applications. They've been tested by developers. They're kind of mature right now. And that's number one. And also, the other advantage of zero-knowledge proof is that it does not require synchronization. Because technologies like secure multi-party computation, it's interactive, meaning that the parties have to be online at the same time in order to execute that computation. But we feel like the idea of decentralization is that you can do whatever computation without waiting for anyone online, right? Just do it by yourself, and your desired party is done. So that's also one part of the advantage, is that it can be non-interactive. You can just do it by yourself, while others can, when they get online at different time, they can still continue the computation or the execution. I think that's another advantage. The third advantage is about the verification. Things like the computational results of, let's say, an Intel SGX execution, the computational results are really hard to be verified. The only way you can verify that is to do remote attestation by sending back the result back to Intel. I feel like it's not very decentralized. But in the case of zero-knowledge proof, everybody on the blockchain can receive that verification key, and you can simply use that verification key to verify, what has been done, and is that done correctly? I think those are the three advantages we've seen in zero-knowledge proof, and we feel like it's the better solution, at least so far. Yeah.
Mm-hmm. Okay, so you talked about using these zero-knowledge proofs, and you talked about one key point, which is that this allows developers to build more dApps. So what kind of dApps do you think are more suitable for a privacy environment?
Yeah, I mean, if you look at fields in finance, healthcare, and possibly some enterprise level applications in human resource management, supply chain management, I think those are the killer apps for this kind of privacy dApps. In finance, you have insurance contracts, right? And also, let's say if you want to do online lending on blockchain, you want to hide your borrower's information, especially their financial status, that can also be very helpful. And also imagine the future of decentralized exchange. I mean, in terms of competing speed, there's no way decentralized exchange right now can outperform centralized exchange. But what if that decentralized exchange have all the privacy features, meaning that all the transactions, all the tradings, and all the order book balance are private, and people can still verify that? That would be very cool to trade crypto assets, right?
Yeah.
I mean, also for the healthcare, you have a lot of personal diagnosis data, health data. It's very critical to hide.
Okay, so Oracle is doing privacy for smart contracts, but there are also other competing products on here on the blockchain space. Enigma is doing also computation that's private. So how is Oracle different from something like Enigma?
As I mentioned briefly, that the technology we're using is very different. Enigma is more on the, I think they're using Intel SGX in phase 1, and then they will gradually migrate everything into secure multi-party computation. Mm-hmm. The technology is very different. We're using zero-knowledge proof. I've named a few advantages of zero-knowledge proof. Mm-hmm. I think that's one big difference. And also, we're also building everything from the infrastructure level, meaning that we're restructuring the whole chain part and also the whole economic system part. For example, we have better designed gas fee models that's tailored for not only normal computation like block validations, things like that, but also like cryptography computation like zero-knowledge proof, because the nature of these two kinds of computation are very different. It makes no sense to use just one gas-free model to do both.
Awesome.
I think that's also very, very different from our side. But doing transaction privacy requires layer one infrastructure kind of change. That's also something we're working on right now.
Cool. And how does your experience lead to developing a blockchain that's privacy preserving? I mean, this is a very, very big challenge, and it's very interesting that you're taking upon it. So how does your previous experience relate to this?
Yeah, sure. I'll just tell you guys a little bit more about myself, right? I was a math background by training. During college, I was one of the outstanding winners, basically meaning like gold medals of ICM. ICM stands for Interdiscipline Contest of Modeling. And after graduation, I started my first company in data solutions for companies. At that time, I really see the need of how companies wanted to protect their data privacy. But that was back in 2013. There wasn't really much going on in privacy technology. There was no ZK Snark, zero knowledge proof, that kind of things. At least in industry, engineering wise. And also blockchain technology wasn't really mature at that time. My first step was around that kind of things. After I sold my first company in 2015, and when I first dig into the blockchain space, I started to kind of just digging to more white papers, more projects, and feel like this is the space that's actually gonna solve all the problems of blockchain being used by real world companies. My personal experience involves a lot of interactions with real world companies. We've dealt something like 400 corporate clients in the past in China alone, both in finance, healthcare, supply chain industry. I would just feel like, why don't we create this kind of cool public chain that all the features of blockchain can be used, while at the same time companies can actually hide their private data, and also the users, the individuals using these kind of applications interacting with these companies can also hide their personal data, right? And that's how we kind of just nail down to this path. It's very hard, as you said. It's very hardcore tech. It's a yes or no question. It's whether you can just do it or not. It's hard, but somehow we managed to do that, and we've finished POC. We've done some sample contracts that can actually hide the things. Yeah.
So that's the current state of it. So you've done a lot of testing already for this system. So what about deployment? When is the testnet and the mainnet going to be deployed?
On our white paper, we're going to. It says we're going to launch our testnet by December this year, and mainnet won't be ready until next year in June. But probably somewhere before December this year, we'll probably give out a demo or something, or like a POC demonstration, just kind of give our fans an idea how this works and how big the market can be applied, because you can simply just replicate some of the applications to other fields.
Right. Cool. And how about your team that's developing this the Origo network? What are your key members?
We have a couple of engineers from tier 1 Silicon Valley technology firms. We have 3 folks from Google, 2 folks right now from Pinterest. We're onboarding several folks from Amazon, things like that. They're very experienced, more than 5 years at least in tier 1 companies in engineering. Frank is leading our infrastructure part, doing all these kind of, we call it tailored scalability for privacy. He's leading the infrastructure team, working on a lot of the better infrastructure by using C++. Yeah, that's one. And also my colleague Ijia and our advisor Howard is leading an effort on the privacy protocol part, which they finished MVP and also the POC already. They did some pseudocoding for some of the applications, one in insurance, one in supply chain. I think the other one is in salary contract on blockchain. Yeah, so it's basically internally we have these two teams working simultaneously on two different subjects. Our POC of privacy preserving smart contract is built on top of Ethereum, just kind of to demonstrate how this protocol works. But then gradually we'll kind of just combine these two efforts by combining our protocol with the chain infrastructure that Frankly is doing. Yeah, so that's how the team is structured. And Howard is the second largest contributor of LeapSnark. LeapSnark is the library of ZK-Snark.
Oh, nice.
Yeah, he's the second largest contributor there. He's the super expert on zero-knowledge proof, and he's our technical advisor. We've been having a lot of conversations on this, and we've also have several PhDs in cryptography. They are very familiar with all the schemas of zero-knowledge proof. Yeah, that's how the team works right now.
Awesome. So we talked about your team. Now we talked about the product. So you're going to open up for a ICO as well. So can you tell me a little bit about the public sale?
Yeah, sure. We are going to conduct a public sale somewhere near this month or next month. It really depending on the preparation work. We're still going through the legal process and also the whitelisting process. We opened up our whitelisting program like 2 weeks ago and got overwhelmed. The community team is working 24/7 by screening out the whitelisting. I think we have quite a lot whitelist.
Congratulations. So can we still participate now into the whitelist?
Yeah, sure. We have different phases of the whitelist. Right now we're having this white paper exam whitelisting. So whoever passes the white paper exam will probably get whitelisted and also get some allocation from the public sale as a secure spot. So just stay tuned with our official Twitter account, official Telegram account. There are people talking about that every day. Ask our admins about the details. I think the test is on the 21st of this month, so you still have some time to study our white paper. We've shoot several videos of like intro to our white paper.
So any tips that we can get to pass this exam? And why did you set up an exam in the first place?
I mean, it's a good way to tell who's really into our kind of technology. Because the whitelist program is overwhelmed, and surely we cannot take everyone in. So at this time, we're happy to be friends and be partners with whoever really understands the tech, really understand the use cases of our technology. And I think for now, that's easier for us to work with, because otherwise we'll be very overwhelmed. We just don't have time to kind of just do a very large scale kind of public sale.
Got it. So you want the people who can contribute to the community and also are genuinely interested in the technology as well.
Yep.
Awesome. Okay, so we have the public sale coming in, and to learn more, you said there's Twitter and there's Telegram. Any other good ways to learn more about this project?
We do have this official YouTube channel. Just search Origo Network through YouTube. There has been some videos about presentations at big conferences, and also the white paper lessons. Cool. And it's pretty cool to learn the project that way. It's kind of techy though.
That's great. And I want to kind of ask this kind of question for you, Liz. Where do you see cryptocurrencies going in the next 5 years?
Well, it's a challenging question, right? Well, I would say right now we feel like the stage of crypto is more like the time around 1999 when people were starting to say that, oh, .com is purely scam. It can only be used for like yellow pages or things like that. But for people who really understand the technology and for people who really understand the needs of the business, who really need this kind of technology, we would say it's similar like that. So in 5 years, definitely there's more use cases of the technology. You will see both governments and companies widely using this kind of technology, all of many reasons. And with that, as some of the tokens function as the gas fee or the fuel of this kind of technology, I would say the token will still continue to exist and also continue to rise as more and more people are actually using that. Instead of just trading them every day on exchanges, right? That's not the ultimate picture we're seeing. The ultimate picture is that people are holding the tokens in order they can use some applications on the platform in the future. And we're confident that's going to happen in 5 years.
Awesome. So thank you, Baron, so much for sharing your insights onto the cryptocurrency developments and also about the Oracle project as well. And thank you so much for your time.
Yep. Thank you, Michael.